Welcome to A-Level and AP Physics. In today's lesson, we will discuss how to sketch reflection, refraction and diffraction diagrams for CAIE IGCSE Physics Exam. In the last video, we have discussed some past paper questions on reflection and refraction in part 01. If you haven't watched that video, you can search the channel for reflection and refraction 01. In this video, we will do more challenging questions from past paper based on reflection, refraction and diffraction diagrams, so you can have clear understanding how to sketch this type of diagrams. Our first question is about reflection. It is also given very clear in this question by reflection at the surface of the water. For this question on figure 6.1, we need to draw the reflected rays and we need to complete the diagram to locate the position of the image. We also need to label the position of the image using letter I. Now let me explain to you how to draw reflected rays. For this purpose, the first step we will follow, this step is we need to draw two normals to the surface, and in second step we will draw reflected rays, and then we will extend reflected rays to locate the image position, and finally we will also label position of the image with letter I. First of all, let's draw normal. First normal we have to draw at this point, so simply you can draw your normal line like this. So this is our first normal, so we can also adjust. So this is about 90 degrees now. Let's draw second normal. We can draw second normal at this point, so this is our second normal. As the normal, it has to be a dotted line, and with no need to draw too long, we can make it little bit shorter. So these are two normal lines. The next step what we need to do is we need to draw reflected rays. For reflected rays, again we need protractor, so we can place our protractor here. We need to measure angle of incidence. In this case, angle of incidence. So angle of incidence is around 47, because angle of incidence is from normal. So this is around 47. This is around 47. So here, so this is our angle of reflection. Angle of reflection is this. We need to simply draw the reflected ray. So this is our reflected ray. This is how we can draw. We can also extend this one because we need to extend to locate image, so simply we can extend, so we no need to redraw again. So this is our reflected ray. Now we need to draw another reflected ray at this point. Again we need to find out the angle of incidence for the second incident ray, and this angle is 28, so it simply means that 62 angle of incidence is 62. So we will go to this side, so angle of incidence has to be 62. This is around 62. Again we have to draw our reflected ray and we will extend this. This is our second reflected ray. Let me a little bit adjust. This is second reflected ray. We can remove this and we can draw small arrows. So in this case our reflected ray means this is arrows important. You have to draw to show direction of reflected ray. Image is located here, so we can use letter I for this one to label this. Extended line should be dotted line, so we make our extended line as dotted line. So like this, we can make this dotted line. So the best way to draw is this has to be dotted line. This is how we can draw, and that's all what you need to do for this question. For part B, it is given to us that an observer sees the image of Q produced by refraction at the surface of the water. Our object is here. This is object vacuum. An image is formed by refraction. By refraction, it means this is about refraction. This question is asking us on figure 6.2, we need to draw possible refracted rays. Possible, it means we no need to worry a lot about angles, and complete the diagram to locate a possible position of the image and label the position of the image using letter J. It is also given to us you don't need to calculate any angles, so we no need to worry about angles a lot. First of all, we need to draw the normal line, so let's draw normal line here. So this is our normal, quite good one. We can use protractor, but if you have some experience you can simply just draw like this. So this is our second normal. We can also make them dotted, so normal has to be a dotted line, so we can make them dotted lines like this. We can make them dotted lines. We need to draw refracted rays. From here we can draw our refracted ray. If there is a no change in medium, this will go in a straight line like this, but in this case there is a change in medium, so it will bend away from normal because waves are moving from denser to optically less dense medium, so it will bend away from normal. So we can draw our refracted ray like this. If you look at these two angle of incidence, this angle of incidence is smaller as compared with this angle of incidence. It means this angle of refraction also will be greater than this angle of refraction. So let me draw a ray here now, refracted ray. So this will bend more. So like this we can draw. We need to extend these refracted rays. We can extend like this. So we can extend like this. These extended lines, they have to be dotted, so we can also make them dotted like this. Our image in this case will be located here. So this is position of the image, and for this one we have to use letter J. So this is image. Only one thing is missing now, that is direction of refracted rays. We must draw arrow. So this is how we can draw. For part C, two identical waves moving towards the boundary at an angle. It is given there are two identical waves, means wave A and wave B. For this question we need to draw on figure 6.2 remainder of the waves A and B and plus two previous waves which reached the shallow water. We also need to use a ruler so we can draw in a proper way. Now first of all, let's try to understand the speed of wave in deep water as compared with speed of waves in shallow water. Speed of waves in deep water is faster as compared with speed of waves in shallow water. Now question is that why speed is faster in deep water? The speed of waves is faster in deep water because there is less friction. So we can say less friction from ground. From ground, so you can say from the seabed, from ground. So this is, so that's the reason the speed of waves in deep water is faster. We can also observe this one in everyday life. If you go to the seaside and you observe the waves coming from the deep sea, you will see the speed is much faster. As those waves they reach the seaside, they slow down. Why they slow down? Because the water near seaside is shallow water and there is more friction from the ground. We will discuss this question in detail so you can have very good idea about this type of questions, and in future you can draw with confidence. I will explain this question in detail, but the remaining question we will just follow shortcut methods. In order to draw refracted rays, we need to extend this ray. So we will extend this ray. So this is our ray. Now the next step, we need to draw normal to the surface. For that purpose we will need protractor, but you can also draw without protractor if you are very confident. If not, we can simply use protractor. So this is how we need to align. We will align our protractor here and we will draw normal line. We will draw normal from here. So this is normal to the surface. We can make it little bit short. We don't need to draw too long. So this is our normal line. Next, we need to draw refracted ray, refracted. So let me change color. If there is no change in medium, this ray will just go in a straight line, waves go in a straight line. But as there is a change in medium, so this will bend towards normal because shallow water is optically denser medium, so it will bend like this. This is our refracted ray. Now we need to draw wavefronts. We will change color and we will draw the wavefronts. For the wavefronts, we need to align this. Wavefronts has to be at angle of 90 degrees to the rays. So we will align first of all this protractor like this. We can also move like this, so it will be easier to draw. We need to complete these waves. So this is over refracted ray in shallow water. We can extend this more and we can draw next refracted ray. This is how we can draw our wavefronts, but we also need to draw arrow on refracted ray. So this is our refracted ray. This is how we need to draw the arrow. That's all for this question. Let's try to understand a little bit more about refraction with the help of this animation. If you watch this animation carefully, you will see that this medium is optically less dense and this medium is optically denser. That's the reason when the waves pass from less dense medium to optically denser medium, they are refracted towards surface. You can see from here, so these ends, if you observe these ends, you can see they are refracted towards boundary, and we will use this idea to answer next questions. For this question, it is given to us that waves are coming from deep water and they're moving towards shallow water. It is also given to us that in shallow water, the waves are traveling more slowly as compared with deep water. So it simply means that deep water is optically less dense medium and shallow water is optically denser medium. For this question, we need to complete figure 5.2 to show possible positions of the 5 wavefronts in the shallow water. Now we need to understand the waves are entering optically denser medium, so they will be refracted towards normal, means they will bend towards normal. So we can draw the wavefronts like this. This is our first wavefront, and the second wavefront we can draw here. The distance also between wavefronts will be shorter, so like this we can draw. We need to keep the same distance between wavefronts, and also they have to be parallel, so this point you need to understand. The last one, this is how we can draw. This is how we can draw the 5 wavefronts in shallow water. If we want to draw the refracted ray will be somewhat like this. This is refracted ray. We can also draw the arrow on this. So this is arrow. So you can see this angle is 90 degrees between ray and wavefronts. In this question, waves are coming from shallow region and they're moving towards deep region. For this question, we need to complete the diagram to show possible positions of the 5 wavefronts in deep water. Now we need to understand waves are coming from optically denser medium to optically less dense medium. So they will bend away from normal, or you can say they will refract away from surface. Only this point we have to keep in mind, and we can draw refracted wavefronts. Refracted away, so this is how we can draw our first wavefront, refracted away, and we can draw the second wavefront. They have to be parallel and the distance between them has to be greater. So these are few points we have to keep in mind when we draw these wavefronts. They have to be parallel and the distance between them has to be longer as compared with the distance between wavefronts in shallow region. So this is how we can draw. So the last one we can draw like this. So this is how we need to draw wavefronts in deep water. If we want to draw refracted ray, we can also draw at an angle of 90 degrees to these wavefronts, somewhat like this. We can also add arrow, so this will be the arrow, and you can see this angle is about 90 degrees. This is how you need to draw wavefronts in deep region.